Welcome to Lesson 224 here on Friday, September 5th, 2025 in Block 3. There is a mistake here because we are in Chapter 2, so this problem is 2-132, but you probably would have figured that out. And let's see what it says by taking a peek in our textbook. It says, begin by fully investigating x equals y squared and x squared plus y squared equals 25 as follows. Without using your graphing calculator, make a table and graph for each equation. Okay, so your first task then is to, we'll call this one x equals y squared. And on the bottom here, this one will be x squared plus y squared equals 25. But your task here for these two graphs is to make the table so that you can make a graph. Okay? These are ones that we haven't necessarily done in this class yet. I don't know how many spots you'll need in your table, so I just filled up the page. You just need as many points as you need till you figure out what this graph looks like. Okay? So I would just start with this one and work together on just plugging something in and get the other thing. Just a real quick though. What do you usually when we make tables, we put numbers in for x and then we plug it into the equation and get y. Since this says x equals y squared, what do you think would be a better suggestion? Putting it in for y, because then you could just square it and get x. So you may want to start with the y's and get the x's from there. All right, so I'll give you some time to fill out as many points as you can in the table, start graphing those points and see what this looks like, and then same for the other one. For those of you watching at home, you don't just fast forward now to the answer. Try it on your own, just like these guys in the class are doing. All right? So we'll just have some downtime here on the video. I'm going to go walk around. How are you doing so far? Charlie, Brandon, Avery, Donna, and Grace. Or if you're watching this in a future semester, then September of 2025. I don't know your names yet. Anyway, I'm going to show you what your classmate Ava M. got. She got a sideways parabola. Did any of you guys? I said to start with the y's, but did you include negatives when you started with the y's? Because negative 3 squared is 9, negative 2 squared is 4, but 3 squared is 9 and 2 squared is 4. So you would include those negative numbers as well. So I totally agree with this particular graph and table. So I'm going to run this packet back to her now. And then momentarily we will talk about x squared plus y squared equals 25. Thank you. And just so you know, as you're working on this, part B was where the book was trying to point out to you that there was multiple answers for some of them. So it says Mary Bell and Lissa were working on this problem, blah, 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 making a table. For an x value of 4, she found a y value of 2. Lissa was watching and said, wait, when x is 4, there's also another possible value. What did Lissa mean? So that's where you were then trying to, the book is trying to guide you through figuring out that 4 is 2, but 4 is also negative 2. So for B, you would just say something like, the x answers have both a positive and negative answer, right? Something like that. 9 is 3 and 9 is negative 3. 1 is 1 and 1 is negative 1, and that's why it's a sideways parabola. So, for this one down here, let me get some feedback from the group now. It is calling on number 10. Hey, number 10, can you tell me one of the points in this table? Just one of the xy points. Number 10 cannot. I will not tell you who that is. All right. How about number 5? Number 5 is whispering to somebody. Do you have any points in this table yet? This person is shaking his or her head no. All right. Now it is calling on 24. These guys are having trouble. Are you guys at home having this much trouble? How about number 6? Nope, Donna. You're watching this video. Do you have one? You can't answer me, though, so I'm going to have to move on to someone else. Now it's calling on 11. Charlie. Oh, you're watching it, too. Hope you have it. I bet you guys do. I have faith in you. Now it's calling on 12. He's the one who sits next to you, Charlie.
3 and...
So you have 3 for x?
and
3 for x and 4 for y, he says. Well, if I plug 3 in for x, I get 9. If I plug 4 in for y, I get 16. I agree with him that 9 plus 16 is equal to 25. So 3, 4 is a point on this graph. 1, 2, 3, 4. I'll just go ahead and plot that point in there. I know that point exists. All right, let me call on another person. You got one yet, number 24?
16 and 2.
Say it again.
16 and 2.
16 and 2. So if I plug a 16 in for x, I will get 196. I know what you're thinking, but you're just not thinking quite right? So think about it a little bit longer. Now it's calling on number 8. Avery, you got it? No, you can't answer me either. 13. She does not have one. Now it's 10. Back to 10. You got one now?
-3 and -4.
-3 and -4. Because that would still be 9 and 16. So that would still work. 1, 2, 3, 1, 2, 3, 4. There's a point. So, hey, you guys at home, you're going to have to take a 30-minute lunch here soon. So when you hear the bell ring, just wait 30 minutes and then we'll continue the video. Actually, I'll stop the video and you just go to part 2. We'll do that. Let's see if we can get one more in before the bell rings, though. How about number 3? Shaking head. 24. Got one yet?
No.
Nope. How about 4? Yes.
Okay, can you flip so you can like change those so that x is 4 and y is 3 and
Yeah. So 4 and 3 and -4 and -3 like that. Right? Because that's still 16 and 9 make 25. So there we have it. 4 is 3 and -4 is -3. So we've got those points so far. After lunch, we will see if we can get the rest of the points needed to see what is happening in this graph. I'm going to stop the video. Have a good lunch, you guys in the room. You guys on the video can keep trying it, and then when you think you've got it, play part 2. Welcome back. As someone was pointing out, was it you?
Was it? I don't know what you're talking about.
Before, right as we were leaving lunch. Oh, was it you? Yeah. Okay, it was Alyssa. Okay. All these 4s and 3s we have there. Of course, if 3 and 4 work and -3 and -4 work, what else would work? 3 and -4, or -3 and 4, or 4 and -3, or -4 and 3. All the combinations of 4s and 3s should work, and that will help get us a bunch more points here. So 3, -4, and -3, 4, and 4, -3. Wait a minute. Stop. Forget that one. Whoa, you can't even see what I'm doing. There we go. And -4 and 3. Ah. So, what's this shape? I've heard of a circle before. Let's see if that's correct. Any other points we can come up with? 5, 0. Is that what you were going to say? All right. Of course, if I say 5, 0, I could also say 0, 5, or I could say -5, 0, 0, -5, all the combinations of 5s with zeros, and that would give me a point right here, 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 and here. Now it looks even more like a circle. Let's just connect all those points we have. And there we have it. So a graph an equation that's in this form, x squared plus y squared equals something, will always be a circle. Okay? An equation in this form, x equals y squared. Well, we already knew y equals x squared was a parabola. X equals y squared is a sideways parabola. So those are just kind of some new equations and graphs. Were these equations functions? They are not functions because they don't pass the vertical line test. It cannot be a function if you've got one x that has two different y's that are that x. So that would make it not a function. All right, so let's try to work through this lesson kind of quickly. Let's see what else it says. All right. It says on part B, I already told you what they're asking for there. You could write something if you want. C says describe x equals y squared and x squared plus y squared equals 25 completely. All right, well, sideways, parabola, circle. Find the domain and range of each equation. What is the domain of x equals y squared? You can see it on your graph. You can see it on your graph. Looks up like that. What's the domain of that? Zero and greater. The domain is all the x values. All x values are graphed as long as they're not negative, right? So I could say something like the domain is x is greater than or equal to 0, or 0 to infinity, right? And the range of this, how about the range? Yeah, it's going up and down forever, right? So the range is all real numbers. And it wants the intercepts. So the x and y-intercept are both just 0, right? X-intercept 0, y-intercept 0. All right, let's go to this one. What's the domain of this circle? Yeah, -5 to +5, and that'd be the range also, right? All the x and y points are somewhere in between -5 and 5. You can kind of see it in the table. All the numbers are between -5 and 5. It also includes all the decimals in between. So I will say the domain is -5 is less than or equal to x, which is less than or equal to 5, and the range is the same thing with y. And as we can see, we've got two x-intercepts of -5 and +5, and that is the same with the y-intercepts for that. So plus or minus 5, I could say, is my intercepts. Okay, moving on. We're going to try to get through this quickly here, because there's still quite a few problems left. But 133 says to rewrite x equals y squared and x squared plus y squared equals 25 so that you could graph them with your graphing calculator. Now, we in this class have been using Desmos as our graphing calculator. Desmos is fine. You could type the equations just like this into Desmos and it works very nicely. But on a normal graphing calculator, when you type an equation in, it has to be in y equals form. It'll only allow you to do y equals. So, for instance, if you take a look at the graphing calculator I have here that I use, if I want to go graph something, I push y equals. In math analysis yesterday, we graphed the equation e to the x power minus 4. And that looks like that. All right. But as you can see, no matter what I type in, it's got to be y equals. All right. So sometimes you have to rearrange an equation so that you can type it into a graphing calculator. So they just want us to practice getting y by itself. If I get y by itself on this equation, what's the answer? Y equals square root of x, right? But here's the problem. If I type y equals the square root of x, you already know what the square root of x looks like, don't you? If I type it into my calculator, here it is. Oop, there it is. Y equals the square root of x. We've already seen that's a square root function, right? So why is it not showing the full sideways parabola? I mean, normally, when we've got something like this, we only include the positives. If I want to take the square root of something to help me solve, we always want to put a plus or minus in front. So I'm going to put a plus or minus in front if I'm solving an equation. That allows me to know that I'm including the negative in front as well. And if I wanted to type that into my graphing calculator, I would have to push negative square root of x also. There we go. And then it would include my bottom half of my parabola. So now let's think about how we'd get y by itself here. And by the way, you cannot square root each side. All right? The square root of x squared plus y squared is not x plus y. Okay? Mathematically, that does not work. Okay? So instead, if I want to get y by itself here, I just literally have to do this. Subtract the x squared over. And then take the square root of each side to get y by itself. But anytime I take the square root to help me solve an equation, I'm going to put a plus or minus in front. And so this would be plus or minus the square root of negative x squared plus 25. I would have to type that into my calculator and then type the negative that to see my whole circle there. All right, but in this class, you're not going to have to worry about that too much because we're not really using graphing calculators. We're on tests, you can't use it, and you can use Desmos to help you once in a while on the assignments. But you'll see that in the future. You'll use graphing calculators in Algebra 3 Trig and later. Okay, we are going to omit problems 134 and 135. So you can cross those out, and we're going to skip on to 136. Okay, so this, in case you don't have your book open, is what 136 says. I think that you can talk through these 4 problems, at least some of them, with your group. So I'm going to give you a couple minutes. Take a look at these, where you'll have to kind of look back to your graph of the circle that you graphed. And it's asking for the radius. Ready, go. Mm-hmm. You're right. So it says, how is the radius of the circle related to its equation? You guys see it? This is a 25, and the radius is 5. So if this had been a 36, you expect the radius would be 6. This is the radius squared, and that's how it'll always work. Okay? So thinking about other graphs that we've done recently, what would you expect the equation to be? Go ahead and guess it if you're not sure. What would you expect the equation to be if it was shifted to having a center at 5, -7, and then with a radius of 10? Okay, so use this as your guide, but it's shifted and then has a different radius. 5 negatives, radius of 10. All right, so I will tell you that it looks like this. Okay? Let's start with this side. What's that going to be? 100, right? It's the radius squared. It'll always be that. Okay, so that side's 100. What do you think goes in here? Go ahead, Dawson. And then y what? Now this is a 7. So y, do you think it's minus 7? So here's the thing. All right, just like you're used to, if you shift it 5 units to the right, you're going to use x minus 5. But on circles, the y will also be the opposite sign, okay? Because it's inside the parentheses, kind of like x is. And so this is going to be y plus 7. So you change the sign for both of them for a circle. All right? And obviously, the second part of that asked, what if it had a radius of 12? That'd just be 144 there, but everything else would be the same. Okay? So just so you know, this is the formula, or this is the equation of a circle. X minus h squared plus y minus k squared equals r squared. So as you can see, they're both minuses inside parentheses for both parts of the center, the x and the y. So you change the signs for both. Okay? If it's negative, it becomes a plus. And then part D says, what if you have this equation? I was just asking for the radius, so you know the radius is 13. But if I also asked you for the center of the circle, where would the center be? 3, negative 7. Just change the signs. So the rules for a circle aren't too hard once you know them. All right, and 137 says to consider this equation. X minus 4 squared plus y plus 1 squared equals 16. Okay? I mean, sometimes the book has really hard problems, and then sometimes they treat you like your elementary school kids. Because the part A says, what's the shape of the graph? So what's the shape of this graph? A circle, because we've just been talking about that. All right, it looks just like the other ones. It says, how could you tell? I'll say it's in circle form. All right. Then it says, what information can you learn about the graph just by looking at the equation? 2 things you could tell from the equation. One is the radius. The other is the center of the circle, right? So, radius and center. And so if we have it in nice circle form like this, they call this standard form of a circle. Okay? We can go ahead and draw the circle. To draw a circle, I just plot the center first. Okay, so the center is 4, negative 1 on this one because it's minus 4 and plus 1, so it would be positive 4, negative 1. Go ahead and plot the point 4, negative 1. There's the center of the circle. Then, since it's equal to 16, our radius is 4. Now, here's how I draw a circle and try to draw it as accurately as possible. If I want to draw a circle with a radius of 4, I go up, down, left, and right, 4 from the center, and put dots in all those spots. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then I just do the best I can to draw a circle that goes through those 4 points. Is yours better than mine? Mine's not too shabby, although, I don't know. And that's it. So, you are ready for assignment 224, hopefully. And I will have a nice, oh man, that's a little bit of a longer assignment. And you can see why we assigned the checkpoint assignment now, because this is the checkpoint. Okay, let's make sure you know how to do this checkpoint. 5x minus 4y equals 7. So I'm doing the last problem on the homework right now. 5x minus 4y equals 7. 2y plus 6x equals 22. First things first. Should I use substitution or elimination on this problem? You can use either one. However, I would say, although if I divided this equation all by 2, then it would be nice. By the way, you could do that. You know that? I'm going to rewrite this equation. Since these are all even numbers, that's legal for you to divide them all by 2 and make the numbers a little smaller. Also, while I do it, I'm going to write the x under the x. So I'm going to write 3x plus y equals 11. Now that I see it like this, it might be the same difficulty either way, substitution or elimination. Because if I use substitution, that would be getting this y by itself. Whoops. That would be getting that y by itself by subtracting the 3x over and then substituting that into this equation. Okay, that would be one way to do this problem using substitution. So then I would have 5x minus 4, 11 minus 3x equals 7, and I would go solve that for x. If I wanted to use elimination for this problem, by the way, what would I do first? Elimination is when you add the two equations together and you eliminate a variable. So what would I have to do first if I wanted to use elimination? Anybody remember if we're back from Algebra 1? So you want the x's and y's are lined up, and then we want something to be the same. Okay? So if I add these as is, it doesn't eliminate x or y. But if this became a 4, then if I added it with this one, the y's would eliminate. So I could make this bottom equation a 4 right here if I multiply the whole thing by 4. So here's elimination. 5x minus 4y equals 7. And now I'm going to take this bottom equation and multiply it by 4 and get 12x plus 4y equals 44. You got to remember to multiply the whole thing by whatever you're multiplying by. Now I could add these equations together and get 17x, cancel, cancel. 7 plus 44 is 51. If 17x equals 51, then x equals 3. Okay, here, if I solve and finish this problem, I better get 3, because no matter which method you do, you'll get the same answer. Let's see, 17x, add 44 over, and I get x equals 3. So no matter what, I'm going to get x equals 3. It's just a preference of whether you like substitution or elimination, or what seems to be the better method for that particular problem. Of course, I'm not done, right? I got to get y as well. Okay, so when you solve a system of equations, you're finding the point that they cross at, so you need the y. I will plug 3 in for x right here. Y equals 11 minus 3 times 3. Y equals 11 minus 9. Y equals 2. So I get a final answer of 3, 2. If you used elimination instead, you would just take that x equals 3 and plug it into one of the original equations and solve for y. You would still get 2. So that's the next checkpoint. So in 10 days from now, we will take a checkpoint quiz over solving systems of equations with substitution and or elimination. All right, so you're welcome to get started on that at some point, but maybe not now because you got some other stuff. Oh, hold on a minute. I think I crossed out some homework problems. Yeah, I did. We're not going to do numbers 140, 141, 145, yeah, just those. So those 3, take those off, and I think you will be happy. You're welcome to do them if you want to, but you don't have to. They won't show up on the homework quiz. All right, since I'm here and I got nothing better to do, let's make sure we know how to do 139. Y equals. I want to write it in graphing form. I want to use the completing the square method. Do you? Ava, you want to use the completing the square method, right? You looked very, what word is that? Enthusiastic. That's what I was trying to say. Yeah. You looked enthusiastic about it. Let's go ahead and do it. X squared plus 7x. Do I want it to be minus 8 there? No, I don't. So I say, get out of the way, minus 8. We're going to put a plus blank there. What goes in the plus blank? We got to do half of 7, which is 3.5. Then we got to square 3.5, and we get 12.25. But of course, I can't just add 12.25 randomly to an equation unless I balance it out. There, I subtracted 12.25 there, so the equation is balanced. And now I can write this in factored form. What always goes here? The half. Yep, the half of 7. So that'd be 3.5. Don't forget, sometimes I see people forget to put the little squared there. Okay, that squared goes there. And then you combine the negative 8 with the negative 12.25, and you get negative 20.25. And that's all it asked us to do, write it in graphing form. All right, so I'm going to go ahead and stop my vid. Ready, break.